All right, guys, today we are going to analyze a quadratic function. Now, before we did this in the previous video, but we were coming up with the equation. Now, I'm going to give you the equation right up there at the beginning. We're still going to graph it, but then we're going to answer questions about the graph. So that's kind of the new part. So let's look up here. It says simplify and graph the following function, then answer the question. So I'm going to simplify it first right here. And by simplifying it, all it means is do that distributive property. Okay, so L times 60 is 60L, and L times L is L squared. Okay, so simplify again just means distribute it out. Let's go over and let's kind of set up the graph. Now, we know down here is our length because it's just like the one we just did on the last video. So down here is our length. This over here is our area. Okay, now for length, I think I'm going to count, let's see if I do tens. Yeah, let's just do tens. So 10, 20, 30, 40, 50, 60, 70, I'll just go to 80. Okay, I think that's going to be enough. Okay, so for our y-axis, our area, we need it to be a little bit bigger. So I was thinking, let's go 100. 100, 200, 3, 4, 5, 6, 7, 8, 9, and 1,000. All right, so I've got my graph set up. So, bunch of different things that you guys can do here. Let me find my calculator. You can plug and check. Okay, I can plug 10 in and see where it goes. I can plug this in and see where it goes. I can plug that in and see where it goes. Or I can put my function in my y equals and get the coordinates from there. So if I go to on, y equals, I already got it in there because I think I was playing around with it earlier. So I've got my 60x minus x squared. Remember, we're not going to put l's in there. You're going to use your variable x. So if you go to second graph, you'll be able to see the table. Oh no, look how mine is starting with 46, okay? I don't want it to start with 46, I want it to start at least with 10 so I can start my graph. So if you want to switch this without doing your arrows, you see that right there, table set? Second table set, I want it to start at, I'm just going to have it start at 0. Then when you go to second table, oh, starts at 0. So we know 0, 0 is the first point. All right, so let's just get a couple points so we can make a couple dots. Okay, so let's do 20. So table set, I'm going to do 20 now. So 20 is 800. I'm going to get a dot up there. Let's do 40. Okay, so I'm just getting a couple dots so I can kind of see where what my graph's going to look like. So 40 is 800. Let's do 30 because what's happening is I've already skipped the vertex, so just let's do 30. 30 is 900, and then we already knew 40 was 800. Sorry, I can't even focus. Okay, let's do 50. 50 is 500. And let's do 60. Let's just use our arrow this time since we probably like the arrow. 60 is 0. So we're back down. Okay, so it's a bunch of different things you can do. You can do your table. You can plug and chug. Okay, it doesn't matter. All right, so I'm going to try to draw this without looking too bad. Well, gosh, I'm the worst drawer. Okay, so just act like that's a great parabola. Okay. All right, so that is what you've been learning the time before, is just putting that graph up. Remember, don't forget to label your axes, get everything down. Let me know kind of what you're doing, okay? Now let's answer the questions. The questions are what is different, okay? Now, it says, what is a reasonable domain of the function in this situation? Remember, domain is your x coordinates. Okay, so what does it go to? Look at your x's here. Here's our x's. It goes from 0 to 60. Now, so it goes from 0 to 60. Now, here's the thing. So let's think about this. This right here means there is a 0 length and a 0 area. Is that going to happen? Do you want, hold on, let me ask another question. Do you want a 0 length when you're building your dog park or whatever? No, you don't. Here, do you want a 60 length with a 0 area? No. So when you're down here on the x-axis, those numbers aren't included. Like you're not going to include 0 in your domain and you're not going to include 60 in your domain. So you don't want the little underlines. Okay, so again, anytime you're down here on the x-axis, because one of your things is 0. Okay, so this one, both things are 0, but this one over here, your area is 0. And we don't want that when we're talking about our dog park. Okay, so no underlines. This is your inequality notation. Let's do our interval just for fun. So remember, if I don't have the underlines, that means I got parentheses. 0 to 60. Boom. Okay? Now let's see what else it wants. Over what interval of the domain is the values of the function increasing? So let me switch over pens. So let's see when we're increasing. So start at the beginning of your parabola. Increasing, 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 increasing. Oh, and then I'm going to start decreasing. So from 0 to what? 0 to what is it increasing? 0 to what? So that dot right there is 30. Make sure you do not put, what is that dot? 900, because we're domain. Domain is your x's, so make sure you stay on your x's. Okay, what do we think about that? I think it's kind of okay, right? Now again, if I wanted to write it in interval, I would do 0, 30. And again, anything on this x-axis, because one of the points are 0, you're not going to include it, so don't write those little underlines. Now let's do interval, the domain, the value is decreasing. So decreasing starts here. Decrease, 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 decrease. So it starts here at 30, and it goes to what? 60. So it starts at 30, and it goes to 60. That is where it is decreasing. It's going down. Okay, so not that bad. You just got to know what increasing and decreasing means. And don't forget, you're just playing with the domain right now, which is only the x values. Don't be looking at the y values. What is the maximum area? So how tall does it go up? 900. Good. What is a reasonable range? Ooh, so now let's do range this time. So range, remember, is your y's. So let me put that right here so you guys remember it's your y's. Okay. So from 0 to what? 900. Good. 0. Don't forget to put a y. 900. Now here's a tricky. 0's on the x-axis. Yes. Is 900. No, it is not. Okay, so 900 does have an underline. Okay, so if I was to rewrite this, it would be 0, 900 bracket. Okay, now this next part we are actually going to use our calculator for. So I've already built in my formula equation still in the y equals. Let's go to our window. And let's set up our window exactly how we have this graph right here. So we're going from 10 to 80, counting by tens. So 10. Well, let's start at 0. Let's start at 0, sorry. 0 to 80, and we're counting by tens. What's our y's going? 0 to 1,000, and we're counting by what? Hundreds. So when I look at the graph, here's the graph. It wants to know, is it possible for a rectangle with a perimeter of 100 to have each area? Estimate the dimensions and find your reasoning. So what you can do is you can go to your y equals. In your y2, you can put the 400 in there. So when you graph it, you can see it. Yes, it's possible to have this 400 feet squared because it hits the graph here and here. Okay, so there's two possible ways. So how do you think we're going to find those two possible ways? Trace, intersect. Okay, so you need a second up here too, my bad. Second, trace, intersect. Second, trace. You see the intersect, number 5? So we're find the intersection between those two things over there. Let's get our blinky over. So you need to start below, enter, then above, enter, and then enter again for fun. So your first answer would be 7.6400. Okay, now let's do the other one. Second, trace, intersect. Get them over there, it takes a while. Enter, enter, enter again for fun. So 52.4 and 400. So 52.4 and 400. So at these two spots, you'll have that area of 400 when your length is 7.6 and your other length is 52.4. Okay? So now let's try it again. Let's try it again now with 500. So if I go back to my y equals, I change that 400 to a 5. Is it going to work this time? Let's see. There's my graph. Get my 5. Oh, yep. So again, 500 is going to be fine. It's going to hit it here and here. So let's do it again just for practice. Second, trace, intersect. Go over here to the left. Remember, always start below on this side. Enter, enter, enter again. So 10 and 500. Now let's try that other side. Second, trace, intersect. When you go over here on the right side, the right intersection, you want to start above the line. Enter, enter, enter for fun. 5,500. So when the length is 10 and 50, your area is going to be 500. Now I want to change this one. I want to change this one to 1,000 feet. Okay, so let's change it. Let's go back to the y equals, go to y2, change that to 1,000 feet. All right, there's my graph. There's my line. See, my line is all the way above. So is there a solution for 1,000 feet? No, because it's not touching your graph. So sometimes it will do that. Like it's going to ask you a question that's not going to work. And that's okay. Check it first using your y equals and see if it's going to work. All right, guys, try your practice problems.